Hello guys, welcome you all for this end-to-end session on AIML where we're going to learn everything that you guys need in order to become a successful data scientist guys. Hope you guys are enjoying. We are enjoying a lot and we are just learning every day a new thing. So yeah, as always, welcome you all guys for this wonderful session where we will be having a combination of theory as well as practical. So hope you guys are enjoying it, and as always, we are also learning and we are teaching. So yeah guys, as always, before coming to the session, make sure you guys have watched all our previous session video so that you can have a better understanding of what we are gonna say. So yeah, that's the only thing from our side guys. So hope you guys are enjoying, right? We have stepped into the field of machine learning, right, where we have started with what is machine learning, the types of machine learning, and along with that we have come to a point, right, where we have discussed about regression and then the theory part and then the coding part, and we have jumped into the classification problem where we have looked into the theory part of logistic regression. Today we will be looking into the coding part of logistic regression. Okay, hope you guys have clarity of what is logistic regression. Whenever if I say logistic regression, what is coming to your mind, guys? I'm just asking you a question, like if I say logistic regression, right, what is coming to your mind? Okay, okay, yeah, how many of you able to understand? Because like last session is a session where I have explained, whenever you say logistic regression, right, this is what you need to understand. Like this has to be visualized in your mind. S curve, right? What is the formula for it? It's simple: 1 by 1 plus e power minus x, where x uh, is a term which is multiple linear regressions term. 1 by 1 plus e power minus multiple linear regression. That's it. Okay. Hope you guys have understand everything. So today we will be going for the coding part of logistic regression. Okay. So first thing, guys, I hope again I'm gonna say this is a collab environment. It is offered by Google. If you guys needs further exploration of this collab environment, please make sure you guys have watched the working with data session which we have done, where we have explored more about this collab environment, how to create it, what are each and every specimens we are having, everything, guys. Okay, so please make sure that you guys have watched that video so that you can have a clarity of what is collab. Okay, today we're going to step into the coding session of this logistic regression. Let's see what it is there. Okay, so guys, first thing, importing necessary libraries. Okay, I hope like if you guys have watched all my previous videos, all of previous videos, then you can know now itself what this code will do. Okay, first is importing necessary libraries. Like pandas is used to perform some data frame kind of operation, whereas numpy is used to perform some numerical operation, that is mathematical operation. Then model selection, which is used to do some kind of training and testing split. And we are having pre-processing, which is used to pre-process our data by using a standard scalar for the range of -1 to 1, any range. Okay, it is used to make the model learn everything in a generalized manner. Then we are having linear model from where we are just importing this logistic regression, because we're gonna play with logistic regression. That's the reason we are having logistic regression. Then we are using the metrics called as accuracy score and confusion metrics. Hope you guys have already know what is accuracy score and confusion metric. They are the evaluation metrics which helps us to evaluate the model which we have created. Otherwise, we doesn't know how well our model is doing. Right? That's it. Okay. So this is all about, you are just importing the necessary libraries. Now, moving on, we are gonna have the loading the dataset. Okay. So for the demonstration purpose, I'm just creating my own dataset by using the make classification library. It's a simple library where you can create your own dataset. Make classification. Number of sample is 100 samples I need, and number of features, that is columns, that is 10 columns, and the class is 2. Since it's a classification problem, I'm going to have a class. How many classes are there? 2 class. One is 0, another one is 1. Then I'm going to set the random state as 42. So whoever running this notebook, right, they're going to get the same result. That is, they're going to get the same data set. Then I'm going to create a data frame. There is a table like structure where I'm going to pass the x, where x is, it has the features. Okay, it has nearly 10 features because we have declared 10, and the sample size is 100. Okay, 100 rows, 10 features. Then I'm just having the things into this data frame. Okay, I'm just executing the for loop so that I can get the shape out of it. Okay, how many times? 100 times it will create, and it will create the features, and then 100 records it will create. That's it. Okay, whereas y is the target value. Okay, you guys can see y will be 0 or 1, so it is going to be 0 or 1. That's it. Okay, when you display the data set, you guys can see here, right, feature 0 to feature 9, because we have declared 10 features, and there is a target variable which has the classification of 0 and 1. That's it. So guys, consider this is a dummy and a toy dataset which we guys gonna work for this logistic regression. Okay, so I hope like this dataset is gonna throw us 100% accuracy, because this is a less complicated data which we have created, and this is gonna follow logistic like normal distribution, so everything will be same. So it's gonna show us 100% accuracy. So only thing you guys need to understand from this session is how to apply this logistic regression, not accuracy, not a kind of metrics, no, nothing. You guys need to know how, when a problem is given to you, how to apply the logistic regression out of it. That's it. Okay, so till this it's everything okay. Then we're gonna summarize our data set. So we're gonna do describe. So describe is very easiest thing, okay, where we're gonna have the summary about the data set, where we are gonna have a count, each thing is 100, and then we're going to have a mean. What is the mean of the column? Like first column is the feature 0 column is 0.038, and for us for the feature 1 column it is minus 0.04, that is a mean. And then similarly we will be having standard deviation, mean, 50%, 25%, 50%, 75, and max. Okay, hope you guys have understand. Okay, then how much value counts are there in target? Okay, that is we are having 0 and 1, right? That's the two classes we are having here. You guys can see it is equally distributed. Okay, 1 there are 50 values, and 0 there are 50 values, that is equally distributed. Okay, hope you guys have understand, and everything is in the integer form, so we doesn't need any kind of manipulation here, because the model can easily able to understand this, because it is in an integer form, that is in a number form. Okay, so then we're gonna check for null values. It's simple, right? We are having dataset name is null dot sum, which will throw how many null values in each and every column. You guys can see there is no null values in any column, and we are having the data type as int. Okay, so it can be digestible by our model. Hope you guys have understand this. So this is a way how we can load, like import the necessary libraries, loading the data set, and then we have summarized our data set, what it in it is, okay, what is inside it, and then we have done for the pre-process. Okay, hope you guys have understand these steps. So we are having further steps. Before that, let's have our sir, like he gonna let us know, because like he gonna tell some more things related to this code. Yes sir, over to you.
Yes. So, guys, go and watch all the sessions, previous sessions, end to end, and do reinforcement learning, and also absorb the information, digest the information, and apply. So, write in the comment section. So, what have you learned? What is your long-term objective function? And how you're going to apply this knowledge? So write in the comment section, and also subscribe to our channels, and also press the bell icon so that you will get notification for each session. So let us go to the logistic regression. Here we'll import the necessary libraries, pandas, numpy, sklearn, and we'll also do pre-processing. A linear model will use logistic regression matrix, accuracy score, confusion matrix. Okay, so then we'll load the data set, and then we'll create synthetic data set uh, with 100 samples and 10 features and one target. Okay, so then we'll get the output. Output is, you can see, according to the whatever of 100 rows into 11 columns. We have this data set. You can see it, you can see the features, see the see the target variable. And let's move to the other section. Yeah, so then we'll see summary of the data set, and it will be based on mean, standard deviation, min, different percentiles, and max. And then you have features. Again, you can see count, that is 100, mean, standard deviation, mean, different percentiles, and max. And so class distribution target is 1, 50, 0, 50. Okay, and name, count, data type, integer 64. So this is the, you will have a summary, and then we'll do pre-processing of the data set and check the null values. So this is the result. So we will print n, checking for null value. Okay, and print data set in null. So these are the like features where we'll see null value, okay, and this is the output. Then we'll go to the segregating data set into input and output. So we have y, x, and y target. Then we are segregating data set into two, input and output. So then we have the output is according to that x and y variable, and target according to that. So we are getting this particular output. Okay, yeah. Then we have y target output. So target output, and then we have x shape, y shape, which is 100, 10, 100. Okay. Then performing feature scaling. So we will use scalar equal to standard scalar, then x scale equal to scalar dot fit transform x. So we have x scale array is the output is this. So you have x scaled output, and yes. So then we'll have x scale shape, that is 100, 10, and then we split the dataset into training and testing. So that we'll do x train, x test, y train, y text equal to train test split x scaled y test size equal to 0.2 random state equal to 42. So then we'll have the output, which is 80, 10, 20, 10, 80, 20. So this is how the output will look like, and it's very simple. So loading the model, we'll have to load the model, guys, and then that is logistic regression, model equal to logistic regression. Then we'll do training. So we'll train x and y variable, and then we'll predict the results of that uh, result of the training. And then we have, yeah, so we'll predict result using the trained model, okay, with y predict equal to model dot predict x test. So y predict will have this array output, and then we'll calculate the accuracy for this model. Okay, and then we'll go and predict the output of single sample using the train model. Okay, and then we'll have the, yeah, so we'll have the predicted class for the new sample 1. So this is how it will be. It's very simple. It's in very simple English language, but it depends on how well you have understood the concept. The application is very simple, and how well you are knowing the libraries and functions using a Google Colab. That will happen once your concepts are clear, once you know what will do what and how it will be done, and you practice a lot. So that reinforced learning will help you. One is understanding the concept, then applying, continuously practicing. So then you will build that consciousness and awareness about applying these concepts and building models. Let's move to the other section.
Okay, guys, actually, sir has explained the entire code. I have stopped in the middle. I will just have the flow because, like, now you have a entire go through of code. So the thing is, I will just end like go through the entire thing, and then we will just complete this session. That's the thing. Okay. So hope you guys have understand this. I'm gonna just release it one more. Okay, we have just imported the libraries, loaded our dataset by synthetic dataset. Then we have just segregated the dataset in like X, that is in a table format, and we have gone for a summarization. Then we gone for a something called as the shape kind of thing we have done, right? So till where we have left, yeah, this is the thing. Okay, so yeah, pre-processing we have left. Now after you have a data set, you need to create input and output. What is our input? except the last column, all are our input. So I need to drop this target column. That is my input. You guys see, this is my X, 10 features, and then I'm having 100 records. What is my output? Y, right? That is target value. So except target value is X, with target value is Y. That's it. Okay. For this everything, we are having target value of one column, 100 rows. That's it. So X shape is 100 comma 10 because 100 records 10 features. Y shape is we are having 100 records but only one feature. That's it. 0 or 1. Okay. Next. Performing feature scaling, guys, this we already know. Okay. Now I just put it here. Guys, see here, there is a combination of minus values and plus values, and there are one extreme to one side and another extreme to another side. Like we will be seeing lots of deviation in it, so that we need to apply the standard scalar so that we can make our model to learn generalized manner. So we are using something called a standard scalar. So it's a pre-processing technique. So scalar dot fit transform of our input x, okay, that is a scaled input, that is x scale. You guys can see now it will be around the range of minus 10 to 10, I think so. Okay, now the model gets more generalized rather than just going for a visualization or just randomly going for something. In order to reduce in accuracy, we are just making something called as a generalization by using this technique which is called as a scaling. Okay, so if without using scaling, what happens means, consider we are having a table where there is two column, one column has a one digit number and another column has a three digit number. If we train the model, it will look into the three digit number and it will give more importance to it. That's the reason it will just eliminate the column with only one digit. Okay, so we need to scale it up. So what happens is both the columns will be scaled in a range of minus 1 to 1, 9 to 1, 8 to 1, 8 to minus 1, like that. Okay, some infinite range. So I will not say infinite, some range. Okay, minus, here there is minus 9 to 9. That is what the scaling factor, that is x scale, which is given thrown for this data set. Okay, once we have scaled it up, then I need to move on to the, so guys, see here, this much is important. Okay, so what is a x scale shape? There is no change, right? We have just done some mathematical calculations. Okay, that is, we have made it normalized. Okay, so that also 100 comma 10. This is the main thing, guys. We need to split our data to training and testing, because like training data we need to give to model only the training time, and testing data are the unseen data which our model will predict based on that how much important or how much this model is working. Everything is based on that. Okay, sure. Next, so for that we are using train test split. We are using train test split. Within that we are having our like x, that is our input x scale, and y, which is our output, and we are having something called as a x test. It is 0.2. The thing is, it gonna take only 20% of data for testing. Okay, random set is 42. As we always know, whenever whoever just run this code, they're gonna get the same output. Next, let us see their shapes. Okay, the input and output shapes. We are having something called as 100 records before, right? So for training we need 80% of records, that is 80 records, and for testing purpose we need separately 20 records. That is what that 20. Okay, 8 comma 10, 20 comma 10, 8 comma 18 comma 10, and 20 comma 10, because like here we are having 20% for testing, right? So whenever it is x test, it is throwing like 20%, and from under 20 is for testing. Other thing is 80, that is for training. That's it. Similarly for the y case, for training it is 80, and then for testing it is 20. Okay, now I'm just loading this model for logistic regression model from the linear model. It's simple. Whenever I need to train, I just need to put model dot fit. Fit is the function which is used to train thing. We are having our x train, and then we are having our y train. That's it. Using that we will just train our model. Fit is used to train the model. So here we have trained it. Once we have trained it, we going for something called as a prediction. Okay, our test data. So training by using the x train and y train. Testing by using the only x test. Okay, how we can test it or how we can predict is means we are having predict function, model dot predict. Since we are having model dot fit to fit the model, similarly we are having a function to do something called as model predict. Okay, so and finally we will be having the result in y predict. Okay, you guys can see this is the result which is predicted by our model. Okay, 0 4 ones, 0 0 triple ones, 0 1, like that. That is a series. Okay, so this is how this y predict occurs due to the trained model. Okay, now I'm going to calculate the accuracy. It's simple. Accuracy score, what is our y test which is present in the data set, and what is the y predict? which is predicted by our model. That is a logistic regression model. Okay, you guys can see the accuracy of the logistic regression model is 1.00. That means what? It's 100%. You just need to multiply it by 100. Okay, and then use a round function to remove the outliers or something called as a colons, anything that you are that is disturbing you. Okay, so that's a major thing that you can do in this. So next we are having predicting the output of a single sample. I hope like you guys already know, right? We need to give 10 features. So you guys see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 features are our input. So I'm going to give the input. I'm going to pass it to the standard scaler because I need to transform it to the scaling part. So that's the way our model is working. Then model.predict. Okay, that is used to predict the, or it is going to ask for prediction for the new data. So this is a new sample that I am having. I'm just passing on to this new sample. Okay. Before that, I have done some transformation, and then it becomes new sample. Okay, and I'm just passing this new sample to the model.predict. That's it. Okay, so you guys can see here now the predicted class is 1. Okay, based on everything the predicted class is now 1. Based on our assumption and POC, the predicted class is 1. Okay, hope you guys have understand. This is simple concept, guys. Actually sir has explained before itself. I'm just explaining in my point of view. Sir is explaining from his point of view, and you guys gonna get both the things. Okay, so I'm just repeating the steps for every machine learning algorithm. It's going to be very same. Okay, you need to import the necessary libraries, loading the data set, summarizing the data set. Then we need to go for something called as a once we have summarized it, we need to split the data set into training and testing. Then we need to go for something like once we splitted it, we need to apply it to the model. That is, we need to train it, we need to test it. Once everything done, we need to evaluate it by using the accuracy metrics, and finally we will test it with the sample data set. Okay, so hope guys this is very understandable, because like it is not like a simple thing as before. Okay, it is one of the proper classification algorithm. Make sure you guys have understand this. If you guys have any doubts, any queries related to this, please don't hesitate to ping us. So we are here to help you. Okay, so hope you guys have enjoyed this session. So yeah guys, that's from my side. Please make sure you guys have watched all the session video. Okay, this is the coding part. Please make sure you watch the previous session so that you can understand the what is the black box behind these logistic regression. Okay, so I hope like this is a very small session but very insightful session. You guys are able to learn this much things. Okay, so like we have created a code part for logistic regression. Hope you guys have enjoyed. So that's all from for this today's session. So if you guys have any doubts, please make sure you put it in the comment box. We will take up and we will solve your doubts. So yeah, that's the thing, guys. If you guys need any support, please ping us. Okay, so until next session, we will all meet you all in next session, guys. Until then, just bye guys. So take care. Yeah, bye.
Yeah, guys, complete all the sessions, do reinforcement learning, go 5 to 10 times, and absorb the information, digest the information, and apply. So, build, write in a comment section what is your long-term objective function of your career, and give us a feedback for each session. If you need any help, we are there to help you. Subscribe to our channels. Also, press the bell icon so that you will get notification for each session. Keep learning with long-term objective function with consistency, persistency, perseverance, and patience. Okay. Then once you have that, then and only you will build these skills. And now skills are key, guys, not degrees and all. So if you build these skills deeply, so you will be always relevant and life become a lifelong learner. Keep learning deeply. Thanks. See you in other session.
Yeah, sure, guys. Thank you. Take care, guys. We will all meet in the next session.